Hello, welcome to the June edition of Theme Park. This month we are discussing about facade engineering, and in this teaser we have with us Brian and Glenn. Hello, Brian and Glenn. Thank you for joining us. Would you like to introduce yourself?
Hi, thanks for having us for Glass Performance Days Theme Park June edition. I'm Brian Koons, an associate at Klein Hoffman.
And I'm Glenn Johnson, principal at Klein Hoffman.
Klein Hoffman's an architectural and engineering firm located in Chicago, Illinois, where we work on a lot of existing building facades as well as new construction.
Part of our work's doing investigations, and shadow box and expandable panels are part of those investigations.
The topic of your paper is simplified method to evaluate shadow box pressure relationship. So why is studying shadow spandrel box cavity pressures relevant?
In contemporary architecture, many buildings have shadow boxes or spandrel panels. They're similar, and shadow boxes generally are more problematic. As the pressurization occurs in the shadow box, the seals are often lost, and they accumulate condensation from or moisture from the inside that turns into condensation you see through the glass.
And whether to seal, pressure equalize, or vent shadow boxes, it's a highly studied subject. However, the opinion is varied across the industry. Therefore, we wanted to do an investigation to look into this further ourselves.
The other thing we encounter is when a shadow box has failed and you're getting condensation accumulation in the shadow box on the glass that you see, finding a way to fix it is very difficult because the failure is occurring well within the system.
And as part of this paper, we included an algorithm which will allow people reading the paper and designers to approximate these pressures early on in the design stages, since currently the only way to do it would be doing advanced finite element analysis or other type of testing, which is not always available early in the design due to project schedule and budgets.
Once the pressures are understood better, the design team can specify different ways to accommodate those pressures and mitigate the potential failure.
And what do you think is the major takeaway from this study?
The study really will show you how to evaluate the amount of pressure that accumulates within these panels in the shadow box cavity. And the outside glass is deflecting outward, the inside metal backband is deflecting inward, and those have different amounts of deflection or softness to them. But in any event, the cavity really isn't large enough, and the materials aren't flexible enough to accommodate that amount of pressure increase without potentially doing damage to the building.
And as we were building the mathematical model, we found some significant takeaways, such as if the panel boundaries, the glass and the back pan, if they're modeled as linear elements in which the stiffness remains constant as it deflects, the resulting pressure is not nearly as high as a more realistic condition, which is a nonlinear panel deflection in which the panel stiffens as it deflects. Using nonlinear panel theory, we found that as the panel deflects, it gets stiffer and eventually it stops deflecting. Therefore, the volume increase does not correlate with the rise in temperature, resulting in a significant pressure buildup.
If you took and looked at this amount of pressure relative to, say, wind load on the building, you'd find the pressure equivalent within the cavity, even with the deflection of the surfaces, far exceeds the wind load pressure on the building, and that can result in the failure of the backband.
My next question is, what are the major pressure-related shadow spandrel box design considerations that are often overlooked?
When the shadow box becomes under pressure, and probably in some respects more on the spandrel panels because of the ability to pressure equalize the shadow boxes, the back pan starts to deflect, forms a canary curve. If the back pan is taking the pressure, whether wind or heat gain and air expansion pressures, it tends to pull away at the perimeter and causes the seals to fail if the back pan wasn't specifically designed to accommodate that type of pressure.
And also another consideration is the load duration. Typically, glass and facade panels are designed for a 3-second wind gust load duration. However, for a sealed cavity, the pressure can remain at its peak for several hours during the daytime when it's in direct sunlight, Therefore, load duration needs to be considered. Glass design is highly dependent on load duration, whereas in which the strength of the glass decreases as load duration increases. Also, many of these IGU panels that are installed in shadow boxes are installed with structural silicone, which also has a low duration dependency. So the strength of the structural silicone might be less than what's typically designed for 3-second wind loads.
Another part that's overlooked is to join and reseal the metal to metal joints. Under a long-term load duration, even a small leak in that would cause the air perhaps from the inside of the building to get into the shadow box or spandrel panel and cause it to condense later when the temperature cools. So all aspects of the cavity, if sealed, has to really maintain the seal to not get the transfer of moisture into that panel. And if unsealed, the loads go down, and it's not such a critical consideration, but you have to now consider where that opening is for pressure relief.
And my last question, what next steps should the industry take related to shadow spandrel box design?
I think the industry has to get consensus standards in place that give guidance to the architects and contractors on the design of a shadow box or a spandrel panel. Right now, there's very little guidance on how to approach this, and we see a lot of different approaches that probably don't make much sense given the particular construction or location. Also, laboratory testing and also in-service testing would be required to look into this issue further. For laboratory testing, inputting a temperature load and measuring pressure increase over time could provide additional information. Installing pressure transducers in in-service current walls could provide data at different climates and sun exposures. Also, looking into whether a sealed shadow box or spandrel cavity box, if you pressurize the cavity, can that cavity actually hold the pressure, or does air leakage result in pressure decline? Not really well considered in the industry is whether the building's in a warm, humid climate or a moderate or a cool climate. And your options for ventilating the shadow boxes or spandrel panel really depend on what climate you're at, and then control of dust or debris or insects into that shadow box have to be considered. And again, the industry really provides no guidance on how to achieve this.
Brian and Glenn, thank you for this small teaser of your paper.
Well, thanks again for having us. It's been great to talk to you about the topic that we've been interested in. I know I've taken a special interest in it for my whole career. Brian, any last closing thoughts?
Yeah, I guess I hope you enjoy the paper, and please let us know if you have any questions or would like to discuss at the scheduled huddle session later this week. We're looking forward to speaking with everyone and working with Glass Performance Days in the future.
Thanks again.
Thank you.
Thank you, and see you in the huddle.